we are graphing inequalities in two variables. There'll be an x and a y in them because we have an x and a y on our coordinate plane. Let's start with, to graph a linear inequality in two variables, graph the boundary. What do you think? First thing you're going to do always, what did you do in those last two problems first? Graph the what? Boundary line. We have to graph a boundary line. Okay, so you're going to have to graph a line, and then you're going to have to make a decision though, once you take your straight edge to draw a straight line, a straight boundary line, you're going to have to decide, should I be making it a solid one, or should I be making it, I call it dashed, that last word she called it dotted. They're the same thing, leaving spaces in other words, not making it solid. So when are we going to make the boundary line solid? When what inequality symbols are being used? When it has the equal to. So if we have is less than or equal to, or we have the is greater than or equal to, we're going to make sure our line is solid. So if it has that equal to bar part, we're making a solid boundary line. It's going to be dashed if it is just is less than or is greater than. No equal to bar. That's when we're going to leave it dotted, dashed, whatever you want to call it. We can generally keep this rule of thumb, and even though that's what we're going to do is we're always going to do a test point, but we're going to shade the graph above or below the line. When do you think we're going to shade above the line? When it is which symbols? Is greater than. Yeah, if we have the is greater than or the is greater than or equal to, our shading really should turn out to end up being above it, the line. It should turn out to be below it if we have the is less than symbol or the is less than or equal to. Okay, and then we're going to test a point not on the boundary line. Now, you can do this test point one of two ways, okay? You can either shade first because you're pretty convinced that you understand that above and below, and then test it to make sure that you shaded the correct side. Or you can do your test point before you shade to help you decide which side to shade. So you can flip-flop steps 2 and 3 here if that works better for you. So testing a point. If a point is in the shaded half plane, so the point that you're testing is in the shaded region, it should make the inequality true. It better make it true. So if it comes from the shaded, it better be true. If the point is in the unshaded, it better make the inequality false. So unshaded, we would get a false statement. And where aren't we going to pick our point from though? Where can't our point come from? It can come from anywhere in the coordinate plane except where? From the boundary line. Yeah, we can't take it from our line. It can't come from our boundary line. Okay. So here's the first one we're going to practice here. We have negative 2x plus 3y is less than negative 15. Well, guess what? You can always put it in slope-intercept form first, do they? So we're going to have to put this in slope-intercept form first. And we're going to put it in slope-intercept form with the inequality symbol in it. Because does anybody remember one of the rules about inequalities that is a little bit different than equations? We solve inequalities the same way, except what? Trey? No, you're right. There's a different type of symbol. You're going to have an inequality symbol. What do we do to solve equations? We either add, subtract, multiply, divide. We have all those things that could possibly go on, right? What's different about inequalities that does not, we don't have to worry about when we're solving equations, right?
The sign changes.
If what?
Multiply, divide.
Yeah, if we end up in the process of getting y by itself, if we multiply or divide by a negative number, the symbol's going to switch. It has to change direction. We have to keep that in mind. Can't forget that. Okay, what's going to be our first move? Negative 2x plus 3y is less than negative 1. We want to get y by itself. What should we do? Trey?
Add 2x to both sides.
Yeah, add 2x to both sides. Add 2x on both sides. And my x can't show up over there because I'm a little bit close on that side, so we'll know that there's an x behind my 2 over here, okay? And now we have 3y. Did we multiply or divide by a negative? No, we just added. So is less than -1 plus 2x.
It's negative.
It's what?
15.
Oh, -15. Okay, thank you. No, I can't see that on there, so thank you for catching that. Okay, what would be our next move? I don't know what, somebody else is gonna be alive besides Trey. Oh, his table partner is, okay, Malcolm?
What? Destruction.
Oh, Stefan? Every piece by 3, yeah. Thank you for remembering that we have to do it to every piece. We're dividing 3y by 3. We're dividing -15 by 3. And we're dividing 2x by 3. Now we have y by itself. Did we multiply or divide by a negative?
Yes. No.
By a negative?
No.
We divided by a positive, didn't we? So we don't have to switch the symbol. -15 divided by 3. -5 plus 2/3 x. 3 doesn't go into 2 nicely, so we leave it 2/3 x. Okay, now we're ready to identify our what? Slope and y-intercept. So, what's our b value? What's our m value? Where do we start when we graph? Okay, what is our b value? -5. And our slope is 2/3, which means we can do +2 over +3, or we can do -2 over -3. Let's stop before we even graph the line. Let's make the decision, should it be a solid line or a dashed line? It should be dashed, okay? So let's write that down so we remember that, okay? Okay, now go ahead, graph your 3 points, at least 3 points. And when you're ready to draw, look over and say, oh, I'm supposed to make the line dashed, so I gotta remember that. It was a positive slope, so I'm feeling pretty good that my line is rising from left to right. Okay. Hopefully you still have some room somewhere, but we still gotta do a test point. Don't we? Okay, we can shade first, test after, or we can test first, shade after. If you want to save yourself some erasing, so you're really good at this, you might want to do the test first. Okay. So, what did that introduction worksheet we did for today, what was the point that they said was a good choice to make for a test point, as long as it wasn't on the line? 0, 0, right? The origin, because multiplying and adding and all that with 0 is a lot easier. So can we test 0, 0? Is it on the line, in other words? No. Here's where 0, 0 is right now, it's right here. It's not on our line, so let's use that as our test point. In fact, why don't you just go ahead and put that point on your graph. We're testing that one. So wherever you have room to do your testing. Now, I'm going to tell you right now, you need to hear me on this, because this is what you're going to do, and then you're going to be like all confused why you're getting them wrong. You're going to say, but Mrs. LeBron, I did my test point. I did it. And it tested true. So that's why I shaded where I did. Where are we going to do our test point, do you think? Trey? In the very original state the equation was in, because what could we have done wrong? Messed up on rearranging it. We could have messed up there. So we're going to go all the way back to where it was in the beginning. How did it start?
-2x plus 3y is less than -15.
Okay, so we're going to write that down.
be meeting.
Okay,
So
thank
you
you.
have them come down to the junior high office, please.
Okay, thank you.
Thank you.
Mrs. Christina McHugh. Okay, so we're testing 0, 0, so that means we're going to put what in for x?
0.
0. What are we going to put in for y? 0. Not much thought going on there, is there? Okay? 2 times 0 and negative 2 times 0, 3 times 0, and we should get. So all we're doing is a substitution. So we hang on the door. You walk down for me, please. Thank you. Okay, so negative 2 times 0 is
0,
0. 3 times 0 is
0,
0. See why that one's so nice? 0 plus 0 is
0,
0. 0 is less than negative 15. True or false?
false.
False. So that tells us what?
Shade below the line.
Shade the other side, yeah. Shade the other side, that 0, 0 is not in. So you just take your pencil now and you lightly shade the region that 0, 0 is not in. And make sure you don't shade over your line because what's going to end up happening is Swiss out of sense. I couldn't tell whether your line was solid or dashed because you got so close to it and so on top of it. Okay, so just go up to it instead of on it. Now, we did the test point before we did the deciding where to shade. So let's go back up here and look and see what it said in number 2. Shade the graph above or below the line. We ended up below, didn't we? Okay. If the symbol is less than or is less than or equal to. Okay. Now, this is one place though where we have to look at after we renamed it. That's where we do have to look at the symbol. Okay. So be careful on this. Hear me on this part. When you're making your decision about shading above or below, if you're going to do that first and then do a test point, you need to do it from this place right here where you put it into slope-intercept form because the symbol might have had to change around in the process. And so you need to have this symbol. Ours didn't change, so it stayed the same anyway. But when we're making a decision about above or below, it has to be in slope-intercept form. That's when we make the decision for that. So this is less than, that would mean shade below, and that's what ended up happening for us, didn't it? Okay, questions at all about that one? Okay, we have another one to do? Okay, let's go get that one done then. Okay, solve 15x, take away 15y is less than or equal to negative 30. Is that ready to graph? No, we gotta get it in slope-intercept form, don't we? Okay, what should be our first move here? We should rename it as add the opposite. That would be a good first move. And then we're going to do what first, right?
Probably add 15y because it's not negatives.
Okay, but then it's going to put it on the other side of the inequality symbol, and sometimes that's confusing for students. So I think I would rather that we leave the 15y on the left side. Okay, we'll leave it over there for now. Isaac?
Subtract 15x from both sides.
Yeah, let's subtract 15x from both sides. I'm not saying we can't move y to the other side of the equation. I'm just saying that oftentimes if we have to read it backwards, it confuses us. So we have a negative 15y, which is what Brighton was trying to eliminate, and they understand that. Is less than or equal to negative 30. I'm going to change this to add the opposite right now too, plus a negative 15x. Now, we didn't have to switch the symbol because we didn't do any multiplying or dividing, right? What's our next step going to be? Every piece has to get divided by that negative 15, okay? Because we want that y to just be y. So we're going to divide every piece by it. Okay, we're dividing by negative 15. What's going to happen? Yeah, but for right now, I'm just showing the work right now, so we don't have to switch it yet. I'm just showing that I'm going to divide every piece by negative 15. And now I I say I divided by a negative, so I need to reverse that. It's going to go from is less than or equal to is greater than or equal to. It has to reverse because we did divide by a negative. Negative 30 divided by negative 15. Positive 2. These guys cancel, don't they? And we end up with just x. Okay, is it in slope intercept form now? Okay, we're ready to go. B equals m equals. Our starting point is 2. What's our slope? 1. So 1 over 1 or negative 1 over negative 1. One more decision before we go to graphing. Dashed line or solid line?
Solid.
Solid because why?
It's equal to.
Because the equal to bar is there. So this time we want a solid line. Okay? So go ahead and graph your boundary line. I like to make, when the slope is especially just 1, I like to make lots of points so I get a good graph. And then with the smartboard, there's still no guarantee. Whoopsie, I'm doing the wrong kind of line. I need solid. Arrows at both ends, just like if we were just graphing the line itself and nothing else. Okay. Let's say this time I decide, you know what, I'm feeling pretty good about this now, and I decide I'm just going to shade first and then I'm going to test. How are you going to make your decision where to shade without testing? What are you going to do? Right?
The side.
Okay, which side?
You're gonna use the side. The one that you wouldn't change, you're gonna shade where it's a little bit, you're gonna shade the back.
Yeah, I got to come back to here where it was in slope intercept form, and I got to look at the simple one. It says is greater than or equal to. Would I shade above or below with the is greater than? Above. So we're thinking that we should be shading over here. Yes, Isaac.
I think I'm gonna have to challenge your graph.
You're going to challenge my graph.
Because your B is. Oh, wait, no.
Okay, you're going to challenge your own instead. Okay. So we say we're going to shade above. Okay, so those of you who think, you know, you're feeling pretty confident that we know what we're doing, let's go ahead and shade it now, and then we'll decide what we're going to test, and we'll see if we're right. Okay? What do you want to test? What point do you want to test? Do you have to test one from which we think is the shaded region? Do we have to? No. We can test one from anywhere but where? Where can we test it from?
On the line.
The line, okay. So could we test the origin, because that's an easy one to do? Yeah, is the origin on our line? No, okay, so here's the origin right here. It's in the unshaded region, so what should happen? It should make it false, shouldn't it? Now, remember, where do we do that test point though in? Which equation? In the original before we put it in slope intercept form. So our test point is 0, 0 again. Trying to save ourselves some work. We have 15x take away 15y equals negative 30. Not equals. Instead is less than or equal to negative 30. Okay. So we substitute our zeros in. I end up with 0 is less than or equal to negative 30. Is that true?
No.
0 less than negative 30? No. Okay, so it's false. So what does that say then? We are right because 0, 0 is not supposed to be in the shaded region, and according to us, it's not. So we're feeling pretty good. Okay, questions? Okay, then I'll look and see if